Hello and Namaste. In continuation with the Z transform, we are dealing here with the Z transform of few standard functions. They play a very important role in solving the different type of examples of Z transforms. So today's session we are dealing here with Z transform of r to the power n cos of n theta, r to the power n sin of n theta, Z transform of cos of n theta and Z transform of sin of n theta. Now, if you'll observe here, this is the very important task which we have done it in the previous sessions. That is, Z transform of a to the power n is nothing but z upon z minus a, and the ROC is mod of z is greater than a. We are making use of this particular task or particular standard formula here to prove this particular formula. Now, putting this in this particular case, we will be putting a equals to r e to the power iq or r theta. You can go ahead with this is nothing but okay. Just a minute. Okay, I think I've done yeah. So this is not q, this is theta. If we will be taking this as theta, so it is nothing but let me just go back here. So if you are putting a equals to r e to the power I theta, so everywhere in this particular formula we are going to put this a is equals to r e to the power I theta. So we'll be having something like this. This is nothing but the same way z upon z minus r into e to the power I theta if mod of z is greater than mod of r. And if you'll observe here, this r e to the power I theta is nothing but r to the power n cos of n theta plus I sin of n theta. This is the expansion of I theta. E to the power I theta is cos of theta plus I times sin of theta. As we have got it here to the power n, because of the De Moivre's theorem, we can go ahead and take this to the power n with the angle. That is what we have done it. We have taken it from the De Moivre's theorem of the complex number. So Z transform of r to the power n cos of n theta plus I sin of n theta, which is equals to Z upon what we have got it here the same way. What this is again getting replaced as cos of theta plus I sin theta. Again, making this is rationalization of this particular, so multiplying and dividing for this particular function as this here with z plus r cos of theta plus I sin theta, numerator and the denominator. If you take this multiplication inside the bracket, we'll be getting this, and the denominator will be z minus r cos of theta the whole square plus r square sin square theta. We are going to get it. This is nothing but we can have it z into this particular function plus I r z sin theta upon this. So just multiplying and just making it a little simple or expanding it, we are going to get this as. Now from here, if we'll observe here, if we'll check this up here, actually yes, fine. This is actually this square should not be here, and this bracket should also not be here, because if we'll expand it, it's r to r cos of theta. Yeah, okay, so this is r square sin square. So this is please make one step here, expand everything, try to get this particular step. I have excluded that particular step from here because just a very simple complex algebra, because we have just multiplying this and adding them up, and just the very simple calculations we are doing it. If we equate the real parts of both the sides, if we are equating real parts of both the sides, so if we are equating real imaginary, so if we equate the real parts of both the sides, we will be getting this identity as Z transform of r to the power n cos of n theta. So if you observe here, this is what is the real part of the function of LHS here, LHS. RHS real part is coming out to be the part which is not with the I. So if you observe z into z minus, so this is z into z minus r cos of theta whole divided by this, which is z square minus 2rz cos of theta plus r square. So this is what we are going to get it as the first, this particular identity or the standard function. Again, if we are equating the imaginary parts of this again here, so if you observe here, this is what is the imaginary part. So Z transform of r to the power n sin of n theta is equals to, now we have to consider this one here, that is Z r sin theta upon this one. So Z r sin theta upon z square minus 2 Z r cos of theta plus r square if ROC is mod of z is greater than r, or you can say mod of z is greater than mod of r. Nothing, there is no problem as such over here. So these are, we have done with this one, we have done with this one. Let us go ahead and explore the next one. It's very simple. I have kept it directly here. We know that Z transform of r to the power n cos of n theta is equals to this. Now, just now we have seen, if we will put r equals to 1 here, that we are going to get this as equals to this. Similarly, if you'll observe here, we have got this particular Z transform of r to the power n sine of n theta is equals to this. If you are going to put the value of r is equals to 1 in this particular case, here, we are going to get it Z sine of theta upon Z square minus 2 Z cos of theta plus 1. That is what we have got it here in this case. Similarly, from this we can easily check whenever we have got cos of n theta, and when we got this n is equals to pi by 2, we can have Z transform of cos of n pi by 2 as Z square upon Z square plus 1. Wherever there is a theta, we are going to put the pi by 2. So cos of pi by 2 is coming out to be 0 here. Similarly, cos of pi by 2 is coming out to be 0 over here. And that means we are going to get it Z square upon Z square plus 1. Similarly, here also, if you are putting this theta is equals to pi by 2, so sin pi by 2 is coming out to be 1. Similarly, this cos pi by 2 is going to be 0. So sin pi by 2 is 1, so that is Z over here. Denominator, this middle term won't be there, we'll be having Z square plus 1 as the Z transform of sine of n pi. These are the different corollaries getting evolved using this particular standard formulae. And this is what about the particular this set of standard formulae. Thank you. Happy learning.